Okay, let me see in Desmos example 1, because Desmos is a confirmation. Okay, everything we are doing by hand is good. Let me try. You open that or no? Yeah, I open. Yeah. Let me share the screen. Here, over there, switching to Desmos quadratic function. Okay, there you go. Do you see Desmos?
Yes.
Okay. It's example 1. Look, I just copy. I copy the equation. I copy the most important point, and also I copy the axis symmetry. No, let me try. Boom. I'm using green color. Okay, the vertex you see now clear is the point 1,8. This parabola up and down. We have one y-intercept at 0,6, and we have two x-intercept in negative 1,0 and 3,0. And I determine one extra point using the symmetry idea in 2,6. And this is super easy, because the distance between the axial symmetry, que es the vertical line, dotted vertical line, to the y-intercept is 1. Travel parallel to the x-axis, no? Therefore, that point is 1,6. So you subtracting is 1 minus 1 is 0,6. And so you adding in another direction to the right, 1 plus 1 is 2,6. So basically the distance is the same. And between that point, I don't know, you see my cursor? How I'm moving? No.
Yes.
You see my cursor how I'm moving? Okay,
Yes.
that point is the y-intercept. That distance is 1. It's obvious, right? And the distance is always 1. That is the reason it's 2,6. And you keeping the same y component, okay, 6. Something, 6, something, 6. This is clear? This is obvious, right? This is straightforward. Any question? Any question? What part is confusing? No? Let's move on to the next problem. Next example. Let's move on to the whiteboard. Okay, no? So far, good. Okay. Off. Okay. No. Sofia dice no. Okay, whiteboard again. There you go. Do you see whiteboard?
Yes.
Let me try to erase everything. And we are doing the example 2. The example 2 is similar example. It's the same job. We are doing the same job. But the problem is that the equation is given like that. So we need to find everything. Vertex, x-intercept, y-intercept, axial symmetry, and finally we are doing the graph of this. Okay. My question now is, this is expressed, this example, in standard or in vertex form?
Standard form.
Standard form, very well. Emily and Elsa say the same thing. Standard form. So immediately I recognize que A is 3, B is 12, and C is 5. No H, no K. You know, H and K I want to find now. But fortunately, we have equation that state the connection between the famous ABC and H and K. Thus I want to explain the super easy way. The super easy way is H is equal minus B over 2A. And this is the most important formula today. And it's no surprise, because you remember the quadratic formula is minus B plus or minus the square root B squared minus 4AC divided by 2A. If you mentally, you eliminate that part, you have minus B over 2A, get that part. So that's super easy. Memorize. It's important and easy to memorize. And to find the K, when we can find the formula also, but no, I don't like this because it's too complicated, and just I never remember that. I basically, K is the Y component to say, now you evaluate the function and function notation, evaluate in the H value that you obtain in this equation. So you have in your hand A, B, and C. You plug it in the formula, K, and close the box. You find the H. To find the K associated with the H, you plug in this value H into the original equation, and you get the Y component. Okay? No formula. No formula. Okay, let's do it. So H is equal minus, the formula have a minus, sorry, don't forget. And B is 12. Multiplication 2 times A is 3. Entonces you apply the order of operation. Remember, when you have fractions, you perform the operation in the top and the bottom independent. This is minus 12 over 6. Es 2, es minus 2. Es minus 2. H is minus 2. And what about K? Well, K, in order to find the K, you evaluate in that function. Let me suppose that you, in your mind, this is function notation, f of x, no? You evaluate in minus 2. So you evaluate the function in minus 2. In other words, you replace x for minus 2. So you have 3 times minus 2 squared plus 12 times minus 2 plus 5. It's 17. I don't think so. I don't think so. No, let's do it. Maybe you're right, but I don't. It's negative 2 squared 4. Negative 2 squared 4. If 4 times 3 is 12. And 12 times negative 2 is negative 24. And 5, 5. But you're subtracting this, and this is minus 12. And minus 12 plus 5 is negative 7, no? Negative 7, es the answer. Because our famous vertex in this example is located at the point minus 2, que es H, comma negative 7, que es K. Cool. I finish. At least the vertex part. Everything is okay? Okay, let me try the rest. The rest is, in what direction open this parabola? In what direction open this parabola? This is my first. It's over. Why? I don't understand. Who is blaming that? He said it open up. Because I need to know the reason, no?
A is positive.
Because A is 3, get positive. Okay, this is the reason. End the story. Number 3 is determine the X and Y in a set. I want to take advantage of this moment to explain one important thing. To find the Y in a set, you know very well that you evaluate in 0 the function. When you evaluate in 0, it's 3 times 0 squared plus 12 times 0 plus 5. It's obvious que 5 because the rest is 0. So in general, guys, this is advantage and disadvantage of the standard and vertex form. And the vertex is easy to see the vertex. It's clear. However, in the standard, it's super elementary. See the Y and Z because it's always Z. Still fine. You don't need to do any operation. Shortcut to doing half of second. The point is 0,5. In general, 0,c value. If my equation is given in standard. See, my equation is not given in standard, well, it's not too hard, but it's a little bit more long. Let's do it now, the x in a set. Well, the x in a set is f of x equals 0. Who is f of x? And our problem is 3x squared plus, let me see, I don't see now, 12x plus 5, and you put equal to 0. It's the same problem that we are doing in the chapter 1. You divide by 3. No, not necessarily divide by 3. No. Now you divide by 3, right? No. Well, you can. Pero no, hello. You solve them by quadratic formula, yes or no? Actually, I determine ABC. I'm plugging in into the quadratic formula and in the story. There is super efficiency and fast way to do that. Okay, so now is quadratic formula. Minus b plus or minus square root b squared minus 4ac divided by 2a. And our specific example is minus 12 because b is 12 plus or minus square root 12 squared minus 4 multiplication by a get 3 multiplication by c get 5. Divide the whole thing by 2 times 3. Okay, as always we are doing, guys, we focus on the expression inside the radical. That expression is the first thing you should do. And your own calculator, you compute 12 squared to 144 minus now multiplication 4 times 3 is 12 times 5 is 60. And you subtracting is 84. And so far, we have the solution is, well, wait, sorry. So now we have square root. Hello, square root this. Unfortunately, 84 is no perfect square number. Therefore, I predict that I have solution that is irrational solution. Plus or minus square root 84 divided by 6. Let me try to find the exact solution, but it's not too important. The important is the approximation. You put it directly in the calculator if you want. But to practice a little bit algebra, let's try 84 is even number. Divided by 2 is 42. Divided by 2 is 21. And 21 is 3 and 7. Oh, nice, I like that. I discovered a couple of 2 inside 84 and represent 1 took a fly outside the radical. So actually we have minus 12 plus and minus 2 radical 21 because unfortunately 3 and 7 is different number. No couple, don't get married, stay inside the radical and you copy no 3 and 7 together. So I copy the multiplication of 21 divided by 6. Okay, I can simplify it. Of course you can, because 12, 2 and 6 is divisible by 2. So one fantastic way to simplification is you divide by 2 is minus 6 plus and minus 2 divided by 2 is 1, radical 21 divided by 3. So the thing I did was divided by 2 here, divided by 2 here, and divided by 2. So you don't understand very well this idea, no problem. I am doing different. I can do, look, I can do, okay, I can do different. This was 2, no, here. You factorization 2 here in the top, 2, so you have minus 6, plus and minus radical 21. And you cancel out this, divided by 2, 1, divided by 2, 3. And we get this answer. But this is not good. It's the exact solution. but I have no idea because it's irrational number. This irrational number, I know it's infinity decimal. I need the approximate answer. Important in the graphic, I need to find the approximate answer. I put in the calculator. And you put in the calculator minus 6 plus like 21 over 6 over 3, sorry. And I put in the calculator minus 6 minus like 21 divided by 3, no? And this is approximate, wrong calculator, minus 0.47. And this is approximately, this symbol indicates it's no exact solution, it's approximation, but to understand much better, I compute that, is minus 3.53. Therefore, we have the parabola que open up, no? Open up, yeah. Have to cross it, the x-axis in 2 points, the point are minus 0.47, 0 and minus 3.53, 0. Okay. I have another questions, complementary. Well, for example, look. Another question, number 4 is the axis of symmetry. Axis of symmetry is always the same. Is the vertical line. X equal h, and our problem was -2. Yeah, get the x component of the vertex. This number, look, this number, -2. Okay. And well, complementary. I include one extra feature, que es domain and range. Domain and range. This domain and range we can find, look in the graph. But I anticipate something. The parabola is a curve like that. Or like that. Open in both directions. So looking in the x-axis, the parabola is infinity in both directions. Therefore, the domain always is from negative infinity to positive infinity. It's nice function. We have no restrictions. Remember, we have restriction only when you have the division, pero the quadratic function have no division, or a square root, and the quadratic function has no square root. Therefore, this happens in not all the function, but in the good kinds of functions. It's nice, no restriction, never accept any value, entonces es all random. However, the range, no. Let me study the range in detail. Okay, we see graphically, but no. So we have a vertex. And remember, range is the y value. Suppose this is the axis, no? X, Y. Entonces, this is the axis, in this case, two possibilities, no? X, Y. It's obvious, look in the graph, okay, the range is from this number to infinity. This is my range. Look. We have no y value here, because the parabola ending here. Similar situation happen here. In this case, the range is down, and we have no parabola up. But we have more. In this case, we have a minimum value, and in this case, you have a maximum value. And you see in the application, guys, we study in a few minutes. I need to find the optimization for the one problem. If the function is the quadratic function, so the only thing you should do is determine the vertex to maximize or minimize, and you determine si es minimum or si es maximum depending of the sign of A. Si A is positive, open up a minimum. Si A es negative, up and down, y es máximo. In this specific example, que the vertex is located at the point 7, no? 7 no. It's negative 2,7. Let me recall. Okay, I forgot. The vertex of this parabola was a negative 2,7. Negative 7, sorry. And our parabola open. In what direction open? Open up. I have a rough idea how it look like. Negative 2, negative 1, negative 2, and negative 7 is 1, 2, 3, 4, 5, 6, 7. Okay, negative 7. This is my vertex. And open up. Something like that. Let's see clear in this one now. And it's obvious que the range, que the y value is from negative 7 to infinity. In that direction. Okay, including negative 7, of course, including negative 7 touch here. Says bracket negative 7, comma positive infinity. And by the way, we have here a minimum because the parabola open up. This idea is clear or confused? It's clear, right? It's clear. It's clear when I explain, no? Confusing. Okay, Michael, what part is confusing? Michael. Confusing. What part is confusing, Michael? Are you joke or something, no? In the range. Okay, in the range. No. It's not confusing because the range. Okay. One more time. Test number 2. How do you see? How do you find the range when you see the graph? Remember, range by definition is the set of y value in which the function is defined. Si es undefined, it's out. But we have parabola only in that part. We have no parabola in negative 8 and negative 9 with negative 10, no parabola. Therefore, the range is the projection of the red curve onto the y-axis. It's obvious from negative 7 to positive 8. Make sense now? Super. Now let's go to the decimals because I want to show you the parabola in detail. Okay, let me see. Here, over there. Do you see decimals?
Yes.
Okay. But this was example 1. Now, example 2 is this. Yeah. Okay, by the way, this is given in the standard, no? You remember that, like that. However, we can modify, or well, not necessarily. I compute H and K. Remember, H and K. H was negative 2 and K was negative 7. And this is the standard, the vertex form, and this is the standard form. And amazing, both are completely algebraically equivalent. Let me show you. Boom. Okay, cool. Look at that. This is my famous parabola. The vertex was negative 2, negative 7. One more I found the y and z, que es 0,5, que es C. Nice. Y solving the quadratic equation associated with the quadratic function, I obtained two x in a set, que es irrational, entonces es crazy decimal, ¿no? Negative 0.47,0 and negative 3.53,0. You want to get another point? Well, we're using the symmetry idea. Look at that, the distance between the axis of symmetry, que es the vertical line, x equal -2, and the y-intercept is 2. Entonces, in another direction, 2 step, 1, 2, you get negative 4,5. Same component of the y, but you moving or subtracting or decreasing the same distance. Okay, interesting. This equation is the red one. Let me put on enable. I put this case the giving at the beginning is giving a standard. Oh, in black color. And you see that they are equivalent. Let me put both simultaneously. And you see only one color, no? The first color. Look at that, flashing. Do you see get the same?
Yes.
What about the domain? What about the domain of this parabola? Well, the parabola is a nice function. Domain is already a number. One super fantastic interpretation is this parabola open in both directions, to the right, to the left. No restriction, already a number, nice. However, the range, oh no, range is not already a number because we have parabola only in that part. Okay, and from -7 touch physically, -7 to +infinity. And -8, and -9, and -10, and -11, and -12, we have no parabola, therefore don't belong to the range. More clear now, Lopez? Yes. Okay. Let's move on to the whiteboard again. One more example. Okay, guys, so now you need to fight with the homework. In the homework, there are a lot of problem complicated of the quadratic. And in the lecture, I using easy value. However, in Alex, no. Because I want to focus on the conceptual part. Pero entonces en Alex, the complication is que I suppose que you have cleared the conceptual part, but the complication is maybe the arithmetic or the algebra. Okay, example 3. Example 3 is different. Example 3 is, let me see some. Yes, there you go. Example 3 is y. So I'm using f of x or y, you know, minus x squared plus 4x minus 5. Entonces, this is expressed en estándar o vertex form.
Estándar.
Estándar. Cool. Entonces, now, si es estándar, immediately in one corner of the piece of paper, I determine ABC. Who help me to determine ABC? Who is A, who is B, who is C?
A is -1, B is 4, and C is 5.
-5. Okay, cool. Now, remember the step number 1 is focusing in the vertex part. And the vertex, when this in standard, I need to use that formula. H is equal minus B over 2A. Entonces, minus, be careful with the signs. Because the formula have a minus, B is positive, but A is negative. 2 times -1, no? Okay, double negative become positive. And 4 divided by 2 is 2. H is positive. In order to find the K, you evaluate the function n2. So you basically replace as -2 squared plus 4 times 2 -5. Be careful, guys. Be careful with the signs. Because you know very well, I suppose, that negative 2 squared is not equal negative 2 squared. So when you have parentheses, it's negative 2 times itself, is 4 positive. However, this no, because you are doing the exponential first, is 4, and you multiply by invisible negative 1 and negative 4. And this is a negative 4, and it's positive 8, and it's a negative 5. And the negative together, negative 4 and negative 5 is negative 9. And negative 9 plus 8 is negative 1. And the famous vertex is located at the point 2, negative 1. Any question? No. Now let's move on to the second step. Determine in what direction open this famous parabola. Open down or open up? No. Open down or open?
Open down.
Open down. Open down. The reason we open down is because A is negative 1. When the A is negative, open down for sure. And this famous point, because the vertex is the point 2, negative 1. Okay, now let's do it now. The step 3 is the computation y in a set and x in a set. Oh, but I know the shortcut. I know the shortcut. I don't need to do anything because it is present in standard. Those are the professor explained me. The value of the c is the y in a set. Thus the y in a set to do nothing is 0, negative 5. That makes sense?
Yes.
Now, now x in a set, well, x in a set is always more complicated. I need to solve in the quadratic equation associated with the quadratic function. Wow, look like weird. Okay, I don't like. Well, you can. Okay, you can using the same value. No, a is negative 1, or b is 4, and c is negative 5. Another student is no, I don't like when you have negative in the front here. You multiply the entire equation by negative 1. Of course, we have completely opposite value of this, but we get the same answer. And some students feel comfortable either way. I don't know. So you multiply the entire equation by negative 1, you have x squared minus 4x plus 5 equal to 0. And when you solve in this equation, it's the same solution. They are equivalent. Okay. What do you prefer? Using the original or multiply by negative 1? Help me. Original, okay, original. He said, what the hell? It's Grace Love. Oh,
sorry, my mic went on. Sorry.
No, you want putting off your microphone? Okay. I can control the microphone. I can control you present here because you have bad behavior. I put outside the classroom. Okay. Okay, so now let's move on. See, I'm using this. I copy my quadratic formula minus b plus or minus square root b squared minus 4ac divided by 2a. In our specific example, b is 4 minus 4 plus or minus the square root. Let me erase that part. I don't need. B squared is 4 squared, 16, I guess so, minus 4 multiplication by negative 1, be careful with the sign, and negative 5. Divided by 2 times negative 1. And remember, I focus 100% in the expression inside the radical. And this is 16, it's obvious, right? And be careful, how many negative signs we have in this expression? 3, 1, 2, 3. Wow, entonces es negative. Si es 2 es positive. Si es 1 es negative. Si es 3, si es odd number of negative es negative. Si es even number es positive. It's 20. Uy, look at that, what's going on. Now I have negative 4, and when you compute that, square root negative 4, I know very well que es imaginary, and the thing I try to find is the real value in which the quadratic function intersect or cross it. The x-axis do not exist because it's imaginary. Entonces the answer is none. We have none, this parabola, and you see now clear when you see the graph in Desmos. We have none, definitely none. Open down, the vertex is located at the point 2, -1. The y-intercept is 0,5 and no x-intercept. No x-intercept. Entonces, bueno, entonces you have only 2 points, professor, to do the graph. Okay, bueno, we're using Desmos and you apply the idea for the symmetry. It's always good. The symmetry is the vertical line, x equal h, and h in our problem is 2. We are doing the vertical line, x equal 2, and dotted line, and taking advantage the symmetry, you determine one additional point to construct our famous parabola. Let's dig in this one. Do you see?
Yes.
This is example 2. This is example 2. The example 3 is now this one. Excellent. We have something like that. Boom! Look at that. This is my equation. Copy. I discover no, I can see the vertex is 2, -1. We determine the y-intercept que was 0, -5. Entonces I have only 2 points. Bam, wow, no enough. And then, using the symmetry idea, you know that the distance from the y-intercept to the symmetry is 2. You see here, 2. 2 plus 2 is 4. The point is 4, -5. And the same height is -5. And you have some idea. And you see that this red parabola never crossed the x-axis. So now, this is a crucial moment to understand the interpretation. When you compute the solution using the quadratic formula, and you get imaginary or complex number, is because in the real axis, because this is real, in 2 dimensions, x-axis is real, y-axis is real, these intercept do not exist because it's complex. Do you understand very well this or not?
Yes.
Okay. So I see application of this. And what real life problems? And the test number 3, we have 2 word problems. But it's super easy. Let me try to explain. Let me try to explain. Let me share the whiteboard again. Okay, there you go. Whiteboard. I bring the image of the PowerPoint I have prepared for this moment. Oh no. Mac 11.5, chapter 3, bang. Let me put both. It's the 2 word problem. Oh. Okay. Okay. Here. Okay. two word problems. Let's do it one by one, no? Suppose this. Let me try it. Read. Word problem is, you know, another skill. You need to read, you need to understand, and you try to solve it, no? Okay, entonces this is quadratic function application. Is suppose que the manufacturer of the gas clothes dryer has found that when the price is $P, the revenue is this equation. Immediately I realize, wow, this equation is quadratic equation. Yeah, I want to copy. So basically, the word problem talking about two variables, P, que is the independent variable, que es the price, and revenue, que is dependent variable, que somehow is connecting by the independent variable according to this formula. Revenue to any price is equal minus 4P squared plus 4,000P. Okay. What unit should be established from the driver to maximize? So basically, it's the optimization problem. I know that this is quadratic function. I know that this is a parabola. And now I want to determine what direction open and everything. And I need to maximize. Okay, so now, this quadratic function is given in standard or in vertex form? Standard. The confusing part is normally the independent variable we call X, but in this case called P, is the same. And this is function notation, revenue to any price. This is Y, no? Entonces, A, B, C. Who is A, who is B, and who is C, in your opinion? Who is A, who is B, and who is C? Sometimes happen in the word problem, one parameter is missing, depending the situation, no? Depending the problem. Who is A, who is B, who is C? Help me.
Minus 4 is A.
Minus 4 is A. And B?
Is 400.
4,000. And C?
We don't have C.
Therefore, it's 0. Es missing. Okay? Es missing. Entonces, I know very, very well que this parabola in what direction open?
Down.
Down. This parabola open down. And the problem talking about maximum money, maximum profit. This happened in the vertex. H, K. Okay, now ready to find H and K. Well, I don't know, so I need to find both. Be careful. Because the question focuses on what price, unit price, should be established for the driver to maximize the revenue. By curiosity, we computed both, but the answer is P. I need to find P. What price you need to establish? And the formula is H is equal minus B over 2A, right? Entonces la fórmula es minus B, que es 4,000, divided by 2 times negative 4, because A is negative 4. Again, one more time happen, que we have double negative, no? And double negative positive. Entonces, basically, multiplication, 2 times 4 is 8, and 4,000 divided by 8, I suppose que es 500, no? Let me check it out with the calculator. 4,000 without signs, because I know the positive, negative, double negative become positive, divided by A, is 500. And this is the price, the optimum price for this driver. Okay, now, curiosity. Do you want to find the maximum revenue? Of course, I want to find, because there is not, it's completely out the question. Because the question is about only what unit price should be established. I did that. Now, let me see how many money I get when you sell. Okay, so now you plugging in, where? In the revenue equation, you plug in 500. Entonces, -4 times 500 squared plus 4,000 multiplication by 500. Okay, of course, we are doing it with the calculator, huh? This is 500 squared. Multiplication by -4 is negative 1,360,000. This is that part. And the other part is 500 times 4,000. Is 20, no? 20. How many zero? 1, 2, 3, 4, 5, 6. No, it's 2 million. 2 million. It's obvious that the revenue is 1 million. I suppose that you sell a lot of this device, no? Okay, it's the gas clothes dryer. You understand the idea? It's super easy. Super easy. 2-word problem. Be aware for this and the test. Okay, let's move on to the next one to understand. This is more practical. It's the smartphone. Okay, this is the marginal cost. Okay, cost. This is different. No profit. There's no money earned. It's a money I spent. Well, I know the manufacturing spent. The marginal cost in dollar for the manufacturing X cell phone in thousand. So X represent 1,000 cell phones. Is given by this formula. Okay, always in this kind of problem, the equation is quadratic, no? 5x squared minus 200 x plus 4,000. This is equation can give me the relationship between the amount, no price, amount of cell phone and their cost to manufacture it. Okay, entonces, how many cell phone should be manufactured to minimize the marginal cost? And what is the minimum marginal cost? Okay, it's similar. Es parábola, ¿no? Es parábola, es expressed en estándar, I guess so. Y I saw que AFI, B is negative 200, and C is 4,000. Entonces, this parabola, in what direction open? Open up or open down?
Up.
Up. Si open up, in the vertex, we have a minimum que I need, because I need to minimize the cost. Okay, cost. But it's important that you understand this idea, right? Remember, optimization is the best option. Si es profit, I want to get a lot of money, so I need to maximize profit. Pero si es cost, it's a bad. I need to pay, so I need to minimize. To minimize or maximize is always in the vertex, and the formula of the vertex is H is equal minus B over 2A. Wow, fantastic. It's the same. And B is negative. The formula, don't forget this negative. And negative 200 divided by 2 times 85. Well, double negative again become positive, and 2 times 5 is 10. Entonces 200 divided by 10 is obvious 20. 20 is the optimum amount of cell phone that you need to to manufacturing, no? To minimize the cost. So you are doing 21. I suppose que the cost is no the minimum. As you are doing 19, it's also no minimum. And the optimum is 20. Okay, super. Now you want to find the cost. How many dollars I need to spend to manufacture 20 smartphone? Okay, so you plugging in 20 in the original equation, get the cost. Fi 20 square minus 200 times 20 plus 400. Let's do it. Calculator now. 20 squared 400, I guess so. Yeah. And 400 multiplication by 5 is 2,000. Guys, I am talking about money now. It's the cost. This is not money. This is smartphone. So it's important that the variable and the equation have different unit, no? Excess smartphone sell and cost is money. Now multiplication by 200 times 20. Oh, 4,000 plus 4,000. Cancel out 4,000. Then the cost, minimum cost is $2,000. Oh, it's no big deal. So you manufacture more than 20 or less than 20, the price is different and it's no minimum. Do you understand very well or not?
Yes.
Cool. It's easy. Guys, I explained so clear. I suppose, no? You let me know, no? But the complicated part, I put easy for my students. Guy, by the way, you enroll with me. You have 2 classes. You have pre-calculus and trigonometric. My recommendation is take together with me. It's Tuesday and Thursday, pero es en person. It's on campus. Okay? Try to enroll or at least separate your seat as soon as possible because maybe when it's full, it's more complicated to enroll you. But if you are a student, was my student, you have priority. Okay, let me spend the rest of the time to introduce a little bit, not too complicated. The new function that we study in this chapter is the rational functions. This is so complicated. Rational function. Period. Okay, rational function is a new function that we study. What is definition? Definition is definition. Definition is suppose rational function. Let me call f of x. It's a name that we are always using to any function. S division 2 polynomial. So P and Q is 2 polynomials. Where P of x and Q of x both are polynomial function. And it's obvious that the restriction is Q of x never 0. Because you know very well what's going on. When you have 0 in the denominator, it's 0 undefined. Okay? I want to study now the different, I bring 1, 2, 3, for example, in which you give the function and you express it in factory form and determine the domain. This is just refresh of another chat. Okay, suppose example 1. I copy a table like that, functions. Copy factory form. Factory form. It's not new, it's factorization only. Factory form and domain. Okay. Function, factory form, and domain. What is important in factory form? Because the first thing that you should do to analyze rational function is factorization. Factorization who? Factorization both polynomial at the top, polynomial at the bottom. Let's do it. In this case, one example, the first one is f of x equal 1 over x. Oh, this is a reciprocal function that we study. Reciprocal function. And it's a rational function. Yes, because in the top we have 1, que es a constant, que es a polynomial degree 0. And in the bottom we have another polynomial que es x, is linear, and the degree is 1. Es super particular, pero es important. Entonces, in the factor form, unfortunately, we cannot do anything. No, because we cannot factorization. 1 is 1 and x is x. This is one typical example in which the factor form and the original function is given at the beginning is the same. Okay, I like that. However, domain es obvio que es a fraction. And remember, don't forget the restriction. That restriction always important. Therefore, the restriction in this case x, que es the denominator expression. No, 0. You can write domain in this notation, que es set builder notation, or in interval notation, the way you prefer. Interval notation is equivalent to say from negative infinity to 0. Of course, 0 not included inside the game. Union 0, infinity. Because in the all real number line, 0, we have a hole. Where? In 0. Okay. Infinity positive, infinity negative. And the middle we have 0. I know que no 0 because to be undefined. Therefore, my domain is that part, but in 0 we have a hole. This piece is this piece, and this piece is this piece. Is it clear?
Yes.
Let's move on to the second example. And let me see something I forgot. In any graph of the rational, we have asymptote. This is a new idea. And what's that? Suppose que, of course, we are doing the graph in Desmos because it's too complicated. But I want to do at least one by hand. The reciprocal function is 1 over x graphic. Look like that. Look, let me show you. We have to branch like that. Yeah, I know, hypothetically, que 0 is to be undefined. No, hypothetical enough, for sure. And here we have on the y-axis, we have one thing, let's call it vertical asymptote. Guys, we're working every day with this. We have vertical asymptote at x equals 0. because you know, okay, when there's 0, okay, when you approach it to 0, to the right and to the left, you see that the number when you compute is. Let me try to explain this idea. This is complicated, very complicated. Well, not complicated, it's easy, but the student don't understand very well. Suppose reciprocal function. We focus on the reciprocal function, at least today, because today we cannot finish this. And you, for example, you approach it, x approach it to 0. To 0 in both directions. Approach it to the right. Let me use this notation. Plus means in that direction, 0 right. And approach it to 0 left. This negative 0 left. Entonces nada, suppose que ahí te approach it to 0, use a 1 over 0.1. I put a small number close to 0, pero positive. When you put in a calculator, the answer is 10. Okay, the answer is 10. Oh, too big. Like that. 10. When you continue approach it to 0 in the same direction, suppose small number 0.01 is 100. And you put 1 over 0.001 is 1000. And you see that our graph blew up to positive infinity. So this guy continues forever to positive infinity. And this is the idea behind numerical acid. Similar, when you approach it to negative, it's the same computation, but negative sign does it approach it to negative. No necessarily always happen in this situation. Entonces, when you study, this is just anticipation, the thing you want to study in detail. Verical acid. It's a line in which the curve go to positive infinity or go to negative infinity. It's important that infinity is a symbolic way to indicate a huge number, positive or a huge number, negative. Do you understand what's confusing that part? Silent. Okay. Forget about this after we study in detail this. But at least you hear an A, verical acid. Okay, now let's doing another example, no? At least today, example 2. Example 2 is easy. It's the function I want to call G, is the name. Is equal, and the top we have monomial, and the bottom we have trinomial. Now, in the factor 4, the only thing you should do is factorization. This is extremely important. Factorization, the top part stay the same because it's monomial, but factorization, the bottom part, no, it's trinomial, and the factorization, I put the easy example, is 3 and 2. 3 and 2 negative of, no? It's the factor 4, and this is the original is given. No? And the domain, well, is when the division, when the denominator is 0. Remember this idea? Okay, I take advantage. This is when the x minus 3 is 0. And when the x minus 2 is 0. It's obvious. Okay, no 3 and no 2. Entonces, the domain you write, in either way, suppose the easy way to write is x such that, and this self-bit denotation, x no 3, comma, x no 2. This is our domain. Entonces, in these 3 and these 2, we have 2 verical acids. I guarantee you that when you plug in 3, or no 3, because 3 is undefined, and 2 is undefined, but close to 3 or close to 2, the number is too big positive or too big negative. This is the idea behind verical acid. Okay. One more. Number 3. It's a function I want to call h. And h is x plus 3 over x squared plus 4. Okay, let me express it in factorial form. Well, at the top, we cannot do anything because it's only one binomial. In the bottom, this is the sum of a square. And the professor in elementary algebra, or intermediate algebra, sorry, explained me that the sum of square is prime. So unfortunately, we cannot do the factorization of this. Stay the same. No, all we happen is when it's possible, you factorization. When it's impossible, you cannot factorization. But the confusing part maybe is, what is the domain? Well, this is the idea behind the domain. Look, the idea is this. I need to avoid que the denominator is 0. Okay, pero we cannot factorization. Okay, no problema. However, you can solve in this quadratic equation. Actually, this is the restriction using that symbol. It's not equal. However, I am strong, familiar, solving any quadratic equation. So for me, it's easy in that way. Now, well, you moving forward to the other side, apply square root both sides, x are equal to say plus and minus, don't forget plus and minus, and the square root negative 4 is 2i. This is the reason. The reason is I cannot factorization is because the solution of this is complex or imaginary. And what about domain? Well, okay, domain, I remember the assumption is domain is always all real number except the restrictions. But when this set out the restriction, I discover that the restriction living in another field, in another planet, in Jupiter maybe, not in our real field. Therefore, the restriction do not exist. Therefore, the domain is all real number. Do you understand this idea? Good or no?
Yes.
Okay. A lot of situations happen. Number 4 situation is the last one. I try to bring a specific example to illustrate the idea behind this. Suppose this function I want to call m of x is x squared minus 6x plus 8 divided by x squared plus x minus 6. This is our example now. Rational. Remember, rational is division 2 polynomial. Okay, immediately I factorization. It's the first thing you should do in this problem, guy. Step 1, step 0, factorization. Trinomial, open 4 parentheses. Then I put x 4 times. And the trinomial at the top, I suppose the combination is 4 and 2, no? 4 and 2, because 4 times 2 is 8, 4 plus 2 is 6, and both negative. Yes or no? And the other no. And the other is 3 and 2, no? 3 and 2. And the sign is different. 3 is positive and 2 is negative. Everyone follow me? Do you understand very well factorization? No? You remember, no?
Yes.
Yeah, absolutely. Hello, professor. Okay, now the new thing, important, between quotation mark. One factor is cancel out. Now my factor form is reduced like that. X minus 4 divided by x plus 3. Okay. Important. The factor que is cancel out is a whole. is to be undefined. It's totally exclusive inside this. And we get a new reduced equivalent equation to this, but this equation is valid if you consider that x is not 2, because in 2 we have a whole. This is important and hard to understand. And what about minus 3, professor? Well, in x minus 3 is also out the domain, because minus 3 plus 3 is 0. But this is not whole. This is vertical asymptote. It's important to recognize, don't worry too much now, because I have 1,000 problems in the review package. You see, and you need to detect see it's a whole or it's vertical asymptote. Both are undefined. Both is out the domain, but this is different nature. To say U factorization, boom. The factor cannot always happen, but sometimes happen. With the factors cancel out, this is a whole. And the factor que stay in the denominator, que es x plus 3, represent the vertical asymptote. End the story. So what is the domain? To finish our lecture today, domain is you include both. Different nature, but both to be undefined for different reason. For x, no negative 2, que es a whole, and comma, or separated by comma, you put and either way for n different to negative 2. Okay, guys, too much for one day. Remember, I need you submit to me today at midnight the Alex and the reading test. The student can do. La majority of the student is doing. Okay. See you. Have a nice day.
You too. Bye.